So here is question number 21, everyone. A ball is suspended by a thread of length L at point O on the wall, forming an angle phi with vertical as shown in figure. The thread is now displaced by angle theta away from the vertical to position A. If the ball is released, then time period of oscillation of pendulum will be what, given that theta is greater than phi and collision is perfectly elastic. Consider the situation. This angle is theta. Now when we release the ball, the oscillation will be like this. The angle subtended here will also be theta. But there is wall in between. There is wall in between and this angle is given phi. So time period initially was what? T equals 2 pi under root L by G. But now the time period will be something different because only this much the ball is oscillating to the right hand side. So this time will be capital T by 2, that is unchanged, but this time will be different. Suppose the time taken by the ball to reach this much is small t. So the total time to reach and then return to position B will be what? 2 into small t. Now capital T by 2 we can easily write. Capital T by 2 is what? Pi under root L by G. And now we have to write 2t, expression for 2t. Consider the angular SHM having amplitude theta at any instant t. The angular displacement phi can be written as theta sine omega t, where theta is amplitude of angular displacement. Now from here we can calculate time very easily. Sine omega t equals phi divided by theta, or omega t equals sine inverse phi divided by theta, or t is equal to 1 by omega sine inverse phi divided by theta. So the time expression also we have calculated. Now finally we can write the total time period t dash will be what? Pi L by G under root plus twice t, further equal to pi under root L by G plus 2. T has the value 1 by omega sine inverse phi by theta. Now we know very well that t equals 2 pi by omega. Therefore omega equals 2 pi upon t, that is 2 pi upon t equal to 2 pi under root L by G. 2 pi cancel. We will get the value of omega as under root G by L. Now we'll put this omega in the expression. What we will get? T dash, the time period, is pi under root L by G plus 2 upon omega under root G by L sine inverse phi upon theta. One more step, pi under root L by G plus 2 times under root L by G sine inverse phi by theta. So finally the expression for time period t dash we can get L by G with under root we can take out as common. So under root L by G common. Within the bracket we will get pi plus twice sine inverse phi by theta. So this is the final expression we have got. Now let us find out the option. We can see clearly that option number 2 is clearly matching with final expression. So we will go with option number 2, which is absolutely correct. Now move on to the next, that is 22 number. Here is question number 22, everyone. Suppose the sound wave in Delhi has been increased by about 1 decibel annually. The number of years in which the intensity of sound doubles will be what? We know very well the sound level intensity is given by SL equals 10 log I upon I naught, where I naught are intensities. Now sound level 1 is given by SL1 equals 10 log I1 upon I naught. Similarly, sound level 2 SL2 can be given as 10 log I2 upon I naught. So change in sound level we can calculate delta SL, that is SL2 minus SL1, 10 common, we can write log I2 upon I naught upon I1 upon I naught. So ultimately we will get I2 upon I1. According to question, I2 equals 2I1, or we can write I2 upon I1 as 2. So therefore change in sound level is what? 10 log I2 upon I1 2. Log, that is base 10, has value 0.3010. So 10 into 0.3010. So change in sound level is what? 3.010, or approximately about 3. So sound level is increased by 3 decibel. Now according to question, 1 decibel increase is in 1 year. So 3 decibel increase will be in 3 years. Therefore 3 years will be the answer, and we'll go with option number 3 only, which is absolutely correct. Now move on to the next, that is 23 number. So here is question number 23, everyone. A charged dust particle of radius 5 into 10 power minus 7 meter is located in horizontal electric field having an intensity of 3.14 into 10 power 5 Newton per coulomb. The surrounding medium is air with coefficient of viscosity neta equals 1.6 into 10 power minus 5 Newton second per meter square. If the particle moves with uniform horizontal speed of 0.01 meter per second, the number of electron on it will be what? Now suppose this is the air atmosphere and this is the particle electric field in this direction, particle experiencing an electric force F electric in this direction. So that's why it is moving in this direction with constant speed. Due to the drag, a viscous force, a drag force is acting in this direction, F drag. Now since particle is moving with constant speed, acceleration 0, net force 0, we can write drag force equals electric force. Drag force 6 pi neta rv, where coefficient of viscosity is neta, r radius, v speed, equals electric force, that is QE, where Q is charge, and we know the charge is equal to integral number of electrons, so N into E multiplied by electric V. Now the number of electrons can be written from here, that is N equals to 6 pi neta rv divided by electronic charge into electric field. Putting the values from the question, 6 into 3.4, that is pi, into neta 1.6 into 10 to the power minus 5 into 5 into 10 power minus 7 into 0.01 whole divided by electronic charge 1.6 into 10 to the power minus 19 multiplied by electric field 3.14 into 10 to the power 5. Solving it, we get number of electrons as 30. So therefore option number 1 we can go with, which is absolutely correct. Now move on to the next, that is 24 number. So here is question number 24, everyone. A uniform electric field of magnitude 3 into 10 power 3 Newton per coulomb is directed toward negative x-axis. So electric field E is 3 into 10 to the power 3 minus I cap. Coordinate of point A and B are shown in figure. The potential difference between A and B along the arc of circle of radius 2 meter is what? conservative field is there which is independent of path. Now electric field is along negative x direction. Particle has displacement along x as well as y direction, but we have to take only x direction because electric field is only in x direction. So therefore delta x we can write 40 plus 20, that is 60 centimeter. So delta x is 60 by 100 meter minus I cap. Electric field and potential are related as potential difference delta V, that is VA minus VB, will be what? Minus E dot delta x. E 3 into 10 to the power 3 minus I cap dot 60 by 100 minus I cap. So I cap becomes 1, minus minus cancel. Ultimately we will get minus of cancel. 3 into 10 cube, that is 1000 multiplied by 6 by 10. Cancel out. 6 3 ja 18. So potential difference between A and B is minus 1800 volt. And after looking at the answer, we can say that option number 4 is absolutely correct. So we'll go with option number 4 only. Move on to the next, that is 25 number. Here is question number 25, everyone. A capacitor of capacitance C is charged up to potential capital V. It is discharged through a small coil of resistance wire embedded in a thermally insulated block of specific heat capacity S and mass M. If temperature of block is raised by delta T, then what is V? Now here thermal energy generated will from what? The thermal energy will be generated from energy stored in capacitor. Thermal energy generated from energy stored in capacitor. Thermal energy ms delta T equals half C V square. From here we have the potential difference V as 2 ms delta T upon capital C. So this is the final expression. Option number 2 is absolutely correct. Move on to the next, that is 26 number.